So this is one of our projected horizontally questions. So okay, we're looking for the horizontal velocity, okay, in this question. So as with all projectile motion questions, okay, we're going to have a vertical component, and we're going to have the horizontal stuff over here. What's the one thing they both share? Time. Okay, the time's the same for both. Once the ball or whatever the object is hits the ground, it's over for both of them. Okay, so since it's projected horizontally, what's my initial vertical velocity? 0. All right, so 0 meters per second. What's my acceleration? 9.81. Okay, it's gravity. Unless you're told otherwise, that's the number. All right, and at this point, we also know that the table is 1.2 meters high, so we know how far it's going to fall down. Okay, we know those three things. Horizontally, right now, I know nothing. I don't know horizontal V, I don't know and I know that, it will travel 0.85 meters horizontally. I also don't know the time. Okay, can I find the time? Okay, same formula that always ends up getting used in this. D equals VI times T plus 1/2 AT squared. Since VI is 0, we can cancel that part out. Okay, and we are simply manipulating for T. So we would divide both sides by half of A and then square root to get T. So that'll be the square root of 1.2 divided by 1/2 times 9.81. Okay, so square root of 1.2 divided by 0.5 times 9.81. All right, so this thing is going to fall for 0.49 seconds. Okay, that can come over here, and now I'm looking at V equals D over T, knowing both of them. 0.85 meters divided by 0.49 seconds, and I'll get my speed. Okay, so 0.85 divided by that number. So I got 1.7 meters per second. Okay. I think I only have 2 significant digits. Okay, is that ringing a bell from last week? Okay, I guarantee you one of your, well, I think you heard this in the podcast for Friday, but one of your questions is a horizontally projected projectile. Okay, and one of your questions is a projected at an angle projectile, which is what we're going to go over today. Okay, so we went over the mega whoosh one, okay, last week. Okay, but I don't know if anybody that when they were younger watched the Dukes of Hazzard. You can't even find it on TV anymore. But okay, they had this orange like Dodge Charger, 69 Dodge Charger, okay, and they would jump it over everything because, well, apparently in the county in which they lived, they didn't believe in bridges. So they always had to jump the car over rivers and whatever else got in their way. Okay, so what we're going to do is we're going to use this, okay, to kind of do a projectile motion question. Okay, I don't have, well, I'm not going to show the video clip because unfortunately the reason you can't watch the Dukes of Hazzard on television anymore is because of one of the things painted on the General Lee, which is a culturally insensitive Confederate flag on the top of their car. So we don't show that anymore. Okay, which was so odd because it was actually quite a wholesome show, but it was so odd that they painted that on the roof of the car when that was so not the message of the show, but whatever. Okay, so what we've got here is that the speed of the General Lee is 32 meters per second when it is launched, okay? And it's going off a ramp, so it's being launched like this, okay? We know that the angle that it is launched at is 20 degrees. Okay, so that's what we know. 32 meters per second, 20 degrees above the vertical as the General Lee goes off of this ramp. Okay, so we want to calculate the distance this thing jumps across the river and the maximum height it will reach in its flight. Okay? So what the General Lee is going to do is it's going to follow what we call a projectile arc. Okay? It's going to do this. It's going to fly through the air in an arc, and then it's going to hit the ground on the other side of the river. Okay, everybody with me so far? So the two things that we're being asked to calculate are this horizontal distance here and the maximum height that the car reaches above the ground. So we're asked to calculate one horizontal thing and one vertical thing. So let's look at what we know right now. Right now we know this. But since this is a vector that is angled, does it have a horizontal component and a vertical component? Right? Any angled vector has an x component and a y component. This one is no different. Okay? What we have to recognize is that horizontally, the object is not going to change velocity. We're operating in the perfect physical world where there's no air resistance or anything that can slow it down. So if I break this up, like I'm supposed to with all projectile motion problems, okay, I can calculate a couple more pieces of information than I'm originally given. Okay? The one other piece of information I'm actually originally given is this. And that's only because in the context of this question, the jump occurs on Earth. Okay? So if I calculate the horizontal component of this velocity, what I'm really calculating is the horizontal velocity the General Lee will fly at through the air. That is, how fast is it going across the river? Okay? So, what trig function would I use to find that? What side of the triangle is that? I'd use cosine. It's the adjacent side. Okay, so V horizontal going to be the cos of 20 degrees times 32 meters per second. Okay, 30.07. All right, so that's pretty fast. I'm going to keep all those decimals in my calculator, but I'm just going to write those. All right, so I calculated that side. That represents the horizontal component of the velocity. Okay, vertically speaking, the object is going to accelerate due to gravity. So when I calculate this side of this triangle, that's only going to be the initial vertical velocity, because as soon as the General Lee leaves the ramp, gravity is going to start trying to bring it back to Earth. Okay? So what I calculate here is the instantaneous initial vertical velocity of the car. Okay? So that's going to be VI. All right? That's the opposite side. So sine of 20 times 32 meters per second. Okay? Just doing vector components like we would have earlier in the unit. Okay, so what this is telling me is that vertically, at least initially, the General Lee is moving straight up at 10.9 meters per second. Okay, that's pretty fast to be moving straight up in the air. But it did, after all, get flung off of a ramp at a pretty high rate of speed. All right, here's the thing we have to assume. The launch point and the impact point, the two shores of the river, are the same height. If they're the same height, how does the final velocity compare to the initial velocity? It's the same. I demoed this last week by throwing a marker up in the air, okay? And I said when it comes back down to my hand, it's moving exactly the same speed I threw it at, because the distance, the acceleration, okay, all of that stuff is the same up and down. So it has to come back at the same velocity it was thrown at, because everything else is the same. Okay, so that means then that I also get VF unless I'm told there's a difference in height. Spoiler alert, we're not doing anywhere there's a difference in height. Okay, so negative 10.9 meters per second. All right, so now I have considerably more information than I had before. Okay, I'm being asked to calculate the horizontal distance and the maximum height of the car. Okay. Let's calculate the horizontal distance first. What am I missing if I want to get the horizontal distance?
Time.
I'm missing time. Okay, we know we have to use v equals d over t for the horizontal part because the speed doesn't change horizontally. Okay, can I get time with these three things? VF, VI, and A, do I have a formula that's got those three things with T in it? I do. Learned it last year in Science 10. Okay, this formula. We looked at it earlier today. Okay, A equals VF minus VI over T. So if I want to manipulate this for T, right, all I have to do is say, all right, T equals VF minus VI over A. So that's going to be negative 10.9 minus 10.9 divided by negative 9.81. Okay, that should give me how long the General Lee is flying across the river. Right, so I'm going to take that number, so I'm going to go negative and then that number, okay, minus that number. And then I'm going to divide that by negative 9.81. Okay, so 2.23 seconds. Okay, that's a long time to be flying through the air in a 1969 Dodge Charger, screaming "Yee-haw!" all the way across, because that's what they used to do if you remember watching the show. Okay, all right, so 2.23 seconds to get across. So now I can put that over here with my horizontal information. And now I can calculate how far it is across the river, V times T. Okay, so I take my 30.07, multiply it by 2.23. Of course, I keep all my decimals for all of this, so that number times that number there. Okay, that's a long way. 67 meters across the river. To put that in perspective, one straight side of the running track is 100 meters. That would be like jumping from the start line to 2/3 of the way down the straight. Okay, it's a long way to be flying through the air in a car. 67 meters. Okay, did I do anything other than vector components, acceleration, and v equals d over t to solve that? It combines those three things, but I don't have to do anything more difficult than finding x and y and using v equals d over t and using an acceleration formula. Okay. All right, so that's finding the distance across. The other thing they want me to find is the maximum height, which occurs halfway through the flight, right? Because you're moving up, and then once you reach the halfway point, you're moving down, 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 down. Okay, in the same way as I demoed last week, when I throw something up in the air, halfway through it, it's at its maximum height, turning around and coming back. So, let me ask you this. How fast is the object going here, vertically? How fast is it going vertically there?
0 meters per second.
0 meters per second. No different than when I threw that marker straight up in the air. At its maximum height, it stops instantaneously before falling back to Earth. So at the maximum height, this is something we just have to remember, at the maximum height of a projectile, the vertical velocity is 0. Okay, so I know that at the maximum height, which I'm trying to calculate, VF is 0. Is VI still 10.9 meters per second? That doesn't change, okay? It doesn't change the way this question started. It just changes that I'm dealing with halfway through instead of all the way across. Okay, so I know VI is still this number, A is still this number, VF is now that number, and I'm looking for D. Do I have a formula that has VF, VI, A, and D in it? Check your formula sheet, guys. See if we have a formula that has those 4 things in it. Which one is it? Eden, you were looking right at it, nodding your head. Which one is it?
VF squared is equal to VI squared plus 2AD.
Yep, that one. Okay, there's actually more than one way to calculate the maximum height. I'll show you the other way in just a minute. Okay, but that way, I've got everything I need. I know VF is 0. I already calculated VI. Okay, I know what A is. It's negative 9.81. So if I want to solve for D, I subtract VI squared over to the other side. And then I divide by 2A, and that will give me D. So that's going to be 0 squared minus 10.9 squared with all the decimals, divided by 2 times negative 9.81. Keeping the negatives in here is important, okay? Because direction matters here. This object is changing direction as it flies through the air. All right, so 0 minus that number squared. Okay, so there's the top, divided by, okay, 2 times negative 9.81. Okay, so the maximum height of the General Lee is going to be 6.1 meters. Is that a long way to fall? Okay, the ceiling in this room is 3 meters, I think. Okay, so imagine falling from twice that height. It would be like being dropped from slightly above the top of a basketball backboard. Actually, it would be the same as being dropped from twice the height of the rim. Okay? That wouldn't work out well. Even if you're a car, you don't want to be dropped from that high. It's going to cause some pretty irreversible damage to the vehicle. Okay? Not to mention that it's also moving horizontally at 30 meters per second. Okay? So, maximum height there, 6.1. Now, there is another way to calculate maximum height, because we do have a lot of numbers here that we can work with. Okay? We do know what VI is. We do know what A is. We're looking for D. And we also know how long the car is flying through the air. But I have to do one thing with that number. If I want to use the time for this occurrence, what do I have to do with it? Divided by 2. The time I calculated is for the entire flight. The maximum height occurs halfway through. It's actually why I don't recommend people do it this way, because everyone forgets to divide the height by 2 and gets that the displacement is 0, which is entirely accurate, because if you go up and down, what's your vertical displacement? okay? So you can use this formula here. D equals VI times T plus 1/2 AT squared. The benefit of this method, no algebra. It's already set up to solve for D. You do have to remember to divide your time by 2 for it to work. Okay, so if I put in my numbers on this one, I'll have my 10.9 times, what was our time here? The time was 2.23 seconds there. Okay, so 1.11 plus 1/2 times negative 9.81 times 1.11 squared. Okay, if I punch all that into my calculator, I'm going to get exactly this number here. Okay, so I'll take my 10.9, okay, multiply it by that number, and then add it to 0.5 times negative 9.81, okay, times that number squared. Whoop, what did I mess up? I messed something up somewhere. Oh, I put a divide symbol in here. That's where I messed up. Instead of multiply, I put a divide symbol in there. There we go. Okay, 6.09 and 6.10, close enough. 6.1 both ways, right? The two significant digits. Okay, so either way will work. Either way is valid on a test, whichever way you prefer. All right, we're going to work on a lot of these angled ones because there's a lot to do in an angled projectile question. It's like doing a 2-vector vector addition question. There's a lot of steps. Steps are always the same, okay? But there are a lot of steps. All right, take a little break from that for a second though, because I want to show you. All right, so for this one here, okay, we got a cannonball fired at an angle of 40 degrees above the horizontal, so much higher angle than our previous question. Okay, and it is fired at 140 meters per second along that vector. Okay, so as with all projectiles, it's going to follow a projectile arc that's going to look like that. We're going to assume that the launch and impact points are level, so there's no change in height. Okay, and we want to figure out how far does it travel. Okay, so horizontally, we're looking for D. Okay, and we're also looking for the maximum vertical displacement or maximum height. All right, so vertically speaking, right off the bat, I know this, negative 9.81 meters per second squared. Okay. Now, what can I calculate since I know 140 and 40 degrees? What can I calculate with those numbers?
Horizontal velocity and vertical initial velocity.
Right, I can calculate the horizontal component to this velocity, which I'm going to need over here. And I can calculate the initial vertical velocity. All right, if I want to calculate that side, what trig function am I going to use? Sine. It's the opposite side. All right, so I'm going to go sine of 40 degrees times the hypotenuse, 140 meters per second. Okay, so sine of 40 times 140. Okay, so 89.99 meters per second, and that would be up. All right, since launch and impact are level, what's VF? What goes up must come down, so they are the same, but negative. Yeah, one's opposite, okay? So this one will be negative 89.99 meters per second. All right, and then on this side here, I can calculate that V horizontal, right? To do that, I'm gonna go cos of 40 degrees times 140. And so 107.25. Okay, so I've got those numbers. If I want to calculate the horizontal distance, I need that. Can I get it? Okay, Sam, you're nodding your head yes. What formula am I going to use?
VF minus VI divided by
Yes. By T, yeah. Okay, so A equals VF minus VI over T. Okay, we're just going to manipulate for T. So that's going to mean that T is going to equal negative 89.99 minus 89.99 divided by negative 9.81. Okay, that'll give us the flight time of the cannonball. All right, so I'm going to go negative that number minus that number. Okay, then I'm going to divide that by negative 9.81. Okay, this cannonball is in the air for 18.34 seconds. That is a long time. Okay, so now that I know that number, I can bring it over here with my horizontal information, 18.34. 34 seconds. Okay, so D equals V times T. I take my 107.25 and multiply it by 18.34. Of course, I keep all the decimals and I don't use those rounded off values. So that number there, A times that one there. Okay, we only have two significant digits, so that's going to end up being 2.0 times 10 to the 3 meters, or 2 kilometers. Is that a reasonable number for a cannonball? Absolutely. Modern artillery shells can travel 100 kilometers. Okay? If modern military call in an artillery strike, they can be calling that in from 100 kilometers or more away. Okay? And they can, those guys can do these calculations like that and drop artillery down, okay, within a few meters of their friendly forces. Okay? It is deadly accurate. All right, the other thing we're supposed to do is we're supposed to calculate the maximum height of the cannonball. All right, what do we need to remember about the maximum height?
Divided by 2.
I either divide the time by 2 or I recognize that VF is, what's VF? Right, 0. Okay, at this point here, okay, VF vertical is 0 meters per second, or I'm using half of that 18.34 seconds, whichever way you want to do it. Okay, I always do it this way. VF squared equals VI squared plus 2AD, because I always forget to divide it by 2, which is what happens to most people. Okay, so D will equal VF squared minus VI squared over 2A. So that'll be 0 squared minus 89.99 squared divided by 2 times negative 9.81. All right, so I'm going to shortcut that and just do this. Okay, so it's going to reach a maximum height of 413 meters. Actually, we only have two significant digits, so 4.1 times 10 to the 2 meters. You'll get the same answer using the other formula. Okay, tomorrow I won't be here again, okay? And I'm sorry about that, but I'm going to go get shots in my back, okay? Okay, so Ms. Vespa will be here again, okay? There will be no quiz tomorrow, okay? I'm going to give you 2 projectile motion questions on Wednesday instead, okay? So we'll get your quiz not on Tuesday, but on Wednesday, so you have some idea where you're sitting with your projectile motion stuff. So tomorrow, she's going to play a thing that's got a few more projectile motion questions, and then you have some time to work on the worksheets from your digital workbook on projectile motion. That's pages 9 and 10. Okay, answers are in there, so you can check your work as you go. If, guys, hey, If there are any that give you trouble tomorrow that you are working on, please make a note of them and ask me on Wednesday, and we'll go through them. Right?
So,